To data management in a Jupyter notebook. Today we'll be learning 5 rather cryptic commands, well make that 6 rather cryptic commands, which will enable us to download some data into a Jupyter notebook and do some basic analysis on it. Now we're going to be using a Jupyter notebook. This is an example from colab.research.google.com, which is a hosting platform for Jupyter notebooks. In order to log in, you'll need a Google account. I'm assuming that you can get to this site, log in with a Google account, and follow along with the tutorial. I encourage you to follow along with all of these commands. They may be a little bit less easy for you. You may find some errors, but if you try it a couple of times, I'm sure you'll get it. Our first command today is going to be an import command. Let me type it first and then explain what it's doing. We're going to import pandas as PD. Now, pandas is the statistical processing package which Python will rely upon. And so we're going to import it because we intend to use it. I've typed the command into a code cell here, and the command executed because I typed Shift Enter. You can also click the play button in order to convince the command to execute. But it does need to execute. We can't just press Enter because that'll make a new line and won't execute that command. When we type this command, what we effectively mean is that the package pandas needs to be imported so that it's available for use. And it needs to be aliased as PD so that we can refer to it as PD. And shortly, we'll do just that. The next thing that we're going to do is we're going to download some data. We'll need to find a data source online somewhere. We'll use the Open Intro Data Repository, which has a wide variety of interesting data sources. Now, rather than downloading the data and then uploading the data to the Jupyter notebook, what we're going to do is we're going to copy the link to the data and then instruct the Jupyter notebook to download it to its own file space. So what we're going to do here is we're going to right-click or context-click on the link to the CSV file. I'm choosing the ACS12 dataset, and I'm going to right-click or context-click on that. And then I'm going to choose Copy Link Address. That puts it in the copy buffer, and then I need to get it into the notebook. In a new code cell, I'm going to use the magic command wget. And then I'm going to place a space and paste the URL using, on my computer, it's Command V. It might be Control V on yours. Notice the command starts with an exclamation point. If it doesn't work, it's probably because you forgot the exclamation point. It also has a space between the command and the URL. This command technically is a shell command dropping down to the Unix shell, but you don't need to worry about that right now. What does it mean? It means go get the file that exists at this location. But I want you to understand that it's an instruction to the cloud computer, which is providing the compute services to this notebook, that it should go get that thing. It's not an instruction to my computer that it should download that thing. I'm going to press Shift Enter in order to execute the command, and I should get some feedback indicating what has happened. It's giving me a little bit of a lengthy report on the connection request and its resolution, and then it's telling me that it saved a file. So now we've accomplished 2 parts of the puzzle. We have imported the statistical processing package pandas and called it PD, and we have downloaded some data, and now it exists in the form of this file ACS12. Where does it exist? If you want to look for it, you can go to the menus here, and particularly the file menu. We now have some example data which exists on all Colab notebooks, but we also have the acs12.csv file that we've downloaded. I want to remind you that CSV is comma separated values, which is a common compatibility format for sharing data. So I'm going to close off this file view. And then the next step that we need to do is we need to read and interpret that file. We need to get an official data frame in the sense of the pandas processing package. So the command that we will use is read CSV. So that's read _ CSV. But the command belongs to the package pandas. And so we're going to type the command in the form pd.read CSV. This dot notation is very, very common in computer science. What this means is that PD is an object which has a certain built-in functionality named read_CSV. And so we're basically directing the object to perform the thing that it knows how to perform. Object.verb is the basic setup here. Now, what do we need to tell it what we want it to read, of course. And so we're going to use parentheses, and we're going to put the file name inside the parentheses, acs12.csv. And I'm just reading that from here, from the report, from the wget command, telling me what was the name of the file saved. Notice that I've placed that file name in quotation marks. It doesn't much matter whether you use single quotation marks or double quotation marks, but we need to have that file name in quotation marks. So this command is an instruction to the PD package to perform the special service read CSV upon the object acs12.csv, which is our CSV file. When pandas performs this function, it will produce a data frame. And this command is not complete as it stands, but I'm going to execute it anyway and then come back to edit it. So when I execute this, what we see is we have a very complicated data frame. And it's displayed for us because it was the last command in this code cell. And so it displayed the result of that command. And that's great. That's exactly what we want. This data frame is exactly what we want to manipulate. But we won't be able to manipulate it unless we give it a name so that we can refer to it by name. It is a data frame, so I'm going to give it a fairly uncreative name, df. And then I'm going to go back and I'm going to change this line so that it reads df equals pd.readcsv, acs12.csv. This will perform exactly the same action. It will instruct the pandas package to read a CSV file, namely acs12.csv, but it will furthermore instruct the computer to assign the result to a variable name that we just made up called df. We could have called it anything we want, but df seems like a reasonable name for a data frame. Now, when I execute this line as it's now been modified, it will change. Well, the output will change. In fact, we'll have no output at all. Notice we have a green check mark indicating success, but we have no output at all. Why not? The thing still produced a data frame, but this was now an assignment. And because we have changed this line so that it is now a variable assignment, the computer politely gets out of the way and doesn't give us any feedback at all. If we are disappointed by that and want to see the data frame, then we can make a new command and we can just put df on a line by itself, and then we will get a display showing exactly what df contains. If you've written this line and it's not quite working, it may be because you've forgotten the quotation marks. It may be because you have forgotten the underscore, or it may be because you've forgotten the parentheses. The computer is rather finicky about the format here, and so we need to type it exactly so. Now, that's 3 cryptic commands which have, in turn, imported the pandas package, downloaded the data, and assigned the data to an official data frame object, df. The next 3 commands will be performed on or by the data frame object itself in order to get various information about it. The first command, which I'm not even going to count as learning something, is to just simply type df itself. Anytime a variable is assigned to a value, if you use that variable on a line by itself, you will see the value of that variable. And in this case, you'll see the entire data frame. But I want to do something a little bit more interesting. I want to use the df.head command. The head is, by default, the top 5 rows of the data. And so I'm going to type df.head. Notice the funny dot syntax again. Now the active object that knows how to do this is the data frame df. And the verb or command that we're sending is head, which means display the top 5 rows. So I'm going to execute this command, and then we should see merely the first 5 rows of that data frame. And there you go. Now, if that didn't work for you, if you're following along and that didn't work for you, it's probably because you disregarded the parentheses that I put at the end here. Whenever a command is meant to execute. It is treated as a function and needs parentheses, even if nothing goes in those parentheses. If I try to execute this command without the parentheses, I won't get what I expect. But if I execute this command with the parentheses, it will do as intended. It's extremely common for beginners to such systems to see parentheses without anything inside them and decide they're probably irrelevant and leave them off. Well, it won't work that way. So make sure to attend to the parentheses there because otherwise it won't do as you're hoping. So the head command on a data frame will simply display the first 5 rows of that data frame. It gives you a sense for what's in the data. It also gives you a quick view of the types of variables that are represented in the data, which might be useful for making further decisions about what you want to do to the data. Notice that this data set has a large number of interesting variables. Most of them are categorical variables like race, gender, citizen, language, married, education. Those are all categorical variables in this data frame. But a few of them, time to work, income, hours work, age, a few of them are quantitative variables. All right, our next command, which is really a catch-all command for all sorts of statistical computations, is the command describe. And like the head command, this command is sort of owned by the data frame, and so we will type df.describe. Again, the dot notation says the data frame is the object, and the object knows how to do something. The verb is describe, and I'm going to use the parentheses to mean I want you to go and perform the function represented by that verb. Let's execute the command and see what happens. I'm going to execute by pressing Shift-Enter. And what do we have here? So notice that although the original data frame has many variables, df.describe is only reporting information about a few of them. Which ones? The quantitative ones. The categorical ones have been disregarded. But for all the quantitative, that is numerical variables represented in the data, we have a wide variety of information provided about them. The minimum value, the maximum value, the median value, which is marked 50% mark, the mean or average value of each variable, the count. Notice the counts are different for all the variables. That's because there are various times in this data set where the data is missing or not provided. It's represented not a number, NaN. And so we don't have data, and so the count is different for the different columns in this data set, but that's all right. We have not only the count and average, but also the standard deviation of those variables. And I mentioned the min, max, and median. This 25% and 75%, we will discuss later. They're called Q1 and Q3. They're quartile values. The df.describe command is a quick and easy command to give you a wide variety of information about your data. If you want to know the average age of the people in the data set, or the oldest or the youngest person in the data set, or the highest income or lowest income or average income or median income, you can run df.describe and you can have all this information at your fingertips. So it's a good, quick first command in order to figure out what's really going on with our data. The last command that we're going to study today is df.core, and its job is to produce some correlation coefficients. It has the same syntax as df.head and df.describe. So let's type it here, df.core, C-O-R-R. And again, since this is a method or function associated to the data frame itself, we will need parentheses. Nothing goes within the parentheses, but we need them anyway. And when we execute this command, we'll see some funny, difficult to interpret stuff. We see, first of all, that the function is deprecated. But that's all right. We don't need to worry about that. So notice that we have a table of values with the same variables, income, hours work, age, and time to work, across the top and down the side. So what that means is that df.core has isolated the quantitative variables only and has given us a table of value of comparisons between the various values. So that this number, for example, is some association between the income and the hours work. whereas this value is an association between the age and the time to work. And this value, for example, is an association between the time to work and the hours of work. These numbers that appear in the result of df.core, these are called correlation coefficients. And we'll give them a lot of attention later, but to be brief, they, roughly speaking, record the relatedness of the various pairs of variables. If you have a positive number here, such as 0.34, then that indicates that there is some correlation or association or relatedness between the variables of hours of work and income. And that relatedness is a positive relationship, indicating the more hours of work you have, the higher your income is, which is fairly natural. If we have a number which is close to zero, such as this 0.02, that basically tells us there's no obvious connection between those two variables. There's no obvious connection that says older people have a longer commute time to work or younger people have a longer commute time to work. Those simplistic statements are not true. So df.core gives you a good quick view into the relationships, the interrelationships between the variables, whereas df.describe gives you a quick overview of the behavior of each variable. So that's it. 6 quick commands: import pandas as PD, wget, pd.readcsv, df.head, df.describe, and df.core. Using these 6 commands, we can pull any data set we want, as long as it's in a CSV file, and we can do some basic introductory analysis of the data, and we can uncover some interrelationships between variables, and we can uncover some thematic values. We can find the means and mins and maxes of various quantitative variables. Now, if you've taken my advice and followed along on a Jupyter notebook of your own, then let me encourage you to do the next most important thing, which is to title that Jupyter notebook within whatever system you're using so that you can find it and understand what's in it later. These 6 commands will be used again and again and again. And at times when you've forgotten the syntax, you're going to want to have something to refer back to. And so give this thing a title so that you can find it and use it as a reference document. Think of it as held in your portfolio of interesting solutions to problems. There's just one more thing I want to mention to you. If you return to this notebook after a long delay, the cloud computer, which is providing compute services to the notebook, will have lost its place and forgotten where you are. If you return after a long delay, which I can simulate by restarting the session here, and then try to execute various commands, df.describe, you'll start getting errors. Errors complaining, I don't know what you're talking about. df is not defined. This is caused by a general loss of context because the cloud computer providing services has completely forgotten its place. There's a simple solution to these problems, which is go to runtime and run all, which will restore all of the state and re-download any resources that need to be downloaded. All right, one last piece of advice. If you do something wrong and you end up getting errors, read them. Read the error text carefully because it's often useful. If you can't figure out what's going wrong on your own, then a quick thing you can do is you can use the share button and you can give link sharing access to me at professor.howell@gmail.com. And as long as you're part of my course, I will have a look and give you some help. All right, that's it. Have a good day.